Welcome back to the virtual classroom of Chem-Based School of Chemistry. Sound clear? Right, today we'll be starting on the final chapter of Unit 1, which is Electrolysis. In this chapter we'll be starting about converting the electrical energy into chemical energy. That's what happens in electrolysis. In short, the term electrolysis, let us see what this term means. Electro is electricity, lysis meaning breaking down. So breaking down of a substance using electric current is what we study under electrolysis. Breaking down of a substance using electric current is what we study under electrolysis. So likewise you will come across later on terms such as hydrolysis. Hydro is water, lysis is breaking down. So if you want to break down, say breaking down a substance using water, is referred to as hydrolysis. That will be studying later on, right? So electrolysis, we use electric current to break down a compound. Like, for example, you have sodium chloride, which is a compound. You can separate the elements in a compound of sodium chloride by electrolysis. You can take sodium and chlorine separately, right? So since electric current is involved in this electrolysis, let us try to understand what is electric current. Now, electric current is defined in chemistry as the movement of charged particles. It's not just movement of electrons, it is the movement of charged particles. Now the charged particles, when I say the charged particles can be electrons, or it can be various ions, meaning cations and anions. Electricity is a movement of electrons or movement of ions, cations and anions. Like electricity can be carried by electrons, or electric current can also be carried by various ions, the cations and the anions. So the electricity in a metallic conductor is carried by electrons, whereas electricity in ionic solution, we know ionic compounds in molten or in aqueous state can conduct electricity, because ionic compounds in molten or in aqueous state, there are free mobile ions to carry electric current. But ionic compounds does not conduct in solid state because ions are not mobile, right? We have studied that under chemical bonding. So ionic solution, it is carried by various ions. So a metallic conductor, we know, say conductor, any substance which carry electric current via electrons are conductors. A substance which does not carry electric current is non-conductor. That means there is no electrons, no free electrons. So be very careful when you define conductors and non-conductors. Non-conductors does not conduct not because there is no electrons. There is no free mobile electrons. Or anything and everything has electrons because it is made out of matter, right? I mean atoms. I mean any matter is made out of atoms. So atoms contains electrons. Even wood, paper, plastic, they are non-conductors, but they have electrons. So having electrons, why they are non-conductors? Because the electrons are not mobile. Likewise, electrolytes are species which contains free mobile ions. So like conductors have free electrons to carry electric current. Electrolytes they contain free mobile ions. So electricity is carried by mobile ions in electrolytes, like electricity is carried by electrons in conductors. As for non-electrolytes, there is no ions, there is no free ions to carry electric current. So electrolyte, the condition for a conductor is that there should be free mobile ions, not just, free mobile electrons, not just electrons, right? So likewise, electrolyte, a substance to be an electrolyte, there should be free mobile ions, not just ions, not just cations and anions, no. If it is a ionic substance, if you take ionic substance in solid state, it's a non-electrolyte, even though it contains ions, even though it contains cations and anions. Is it clear? So you know what is electrolysis? Breaking down of a substance using electric current. What is electric current? Movement of charged particles, can be electrons or ions. And conductors, substance which carry electric current using electrons. Electrolyte, substance which carries electricity by presence of free mobile ions. Okay. So let us write the answers here. What is electric current? Movement of charged particles. Movement of charged particles. You can write in brackets electrons or ions. What carries electricity in metallic conductors? Free mobile ions. Free mobile ions. Next question, what carries electricity in ionic solution? I'm sorry, metallic conductor has free mobile electrons. Okay, there are free mobile electrons. Ionic solution, free mobile ions. The B answer is free mobile electrons. The C is free mobile ions. And for definition of conductor, any substance which carries electricity via free mobile ions. Substance which carries electricity or electric current via free mobile electrons. Conductors, electrons. Non-conductors, substance which does not carry electric current. Substance which does not carry electric current due to absence of free mobile ions, free mobile electrons. Substance which does not carry electric current due to the absence of free mobile electrons. Next is electrolyte. Substance which carry electric current. Substance which carry electric current via free mobile ions due to the absence of free mobile ions. Due to the absence of free mobile ions. So non-conductors and non-electrolytes, they don't conduct, but the thing is, non-conductors doesn't conduct because there's no free mobile electrons. Non-electrolytes does not conduct because there's no free mobile ions. So that's the difference. So conductors and electrolytes both conduct electricity, but conductors conduct electricity via free mobile electrons, whereas electrolytes conduct electricity via free mobile ions. So that's the difference between conductor and electrolyte. But both conductors and electrolytes, they conduct electricity. But how they conduct electricity is what differs. Conductors, free mobile electrons; electrolytes, free mobile ions. Give common examples for electrolytes and non-electrolytes. Electrolytes, of course, we won't be studying about conductors and non-conductors here. In this chapter, only electrolytes and non-electrolytes, because I just mentioned about conductors and non-electrolytes because the difference you should understand, because many think electrolytes are conductors. Of course, they are conductors of electricity, but the mode of conductance is different, right? So electrolytes, There are so many common examples for electrolytes. You can say any ionic substance in aqueous or in molten state. They are electrolytes. Now, any ionic compound in solid state won't be electrolyte, because in solid state, ions are in fixed positions. They are unable to move. But in aqueous state, aqueous meaning dissolved in water, or molten state, molten meaning heated and melted, then such will conduct electricity, because there's free mobile ions or electrons to carry electric current, right? So all ionic compounds in aqueous or in molten state, they conduct, and acids and alkalis do conduct electricity, because acids and alkalis, they contain cations and anions. Any acid contains H plus and A minus. A minus is the anion, right? So in contrast to covalent compounds, of course, covalent compounds are non-electrolytes, because there's no ions in covalent compounds, except for, of course, acids. All acids are covalent, but because hydrogen never form ionic bonds, we know that. We discussed that in under chemical bonding. The hydrogen will never form ionic compounds. They always form covalent molecules. So, except for acids, because acids are, of course, electrolytes, and the other covalent compounds are non-electrolytes. And also ionic compounds in solid state, they are non-electrolytes. They will not carry electric current. So you can write some common examples here for electrolytes. All ionic compounds in aqueous or in molten state, we use this simple setup here. You can see a simple apparatus here. You have the battery, the bulb, and the electrolyte. This is actually a substance under test. It can be electrolyte or a non-electrolyte. And you can see two rods here. Now these two rods are conducting materials. They are known as electrodes. So these electrodes are conducting materials which is dipped in an electrolyte to facilitate the movement of the charges. Now these electrodes are unreactive rods. That means to select a substance to be an electrode, there are two conditions. One, it should conduct electricity via electrons with a solid. Second, that particular substance should not react with the substance under test. It should not react with the electrolyte. Generally we use carbon rods, graphite rods as electrodes, because they are non-metals, plus they have free mobile electrons in graphite, good conductor. Or we can use like inert metals, meaning unreactive metals such as platinum. Platinum is unreactive metal. Even if you put that platinum in acid, it won't react. Right, but only thing with platinum is usually we don't use in the lab because it's very expensive. Other than that, we can use platinum. Generally what we use is the graphite rod. Any other metal like magnesium or any other metal we don't usually use, because it will start reacting with the electrolyte. So you have substance under test here, and the battery and the bulb. So if it is an electrolyte, then it will carry electric current, which will be shown by the bulb becoming illuminated. The bulb will light simply if it is electrolyte. If it is non-electrolyte, the bulb does not light. So that is how we test for electrolytes and non-electrolytes. Clear? So the electric current through the electrolyte is carried by various ions, cations and anions, and through this conductor, right, up to other end, it is carried by the electrons. So electrons carry electric current in the solid conductor, and solution, if it is an electrolyte, it is carried by cations and anions. I'm going to explain to you later on how these cations and anions enable the movement of the electric current, right? Okay, this apparatus setup is known as the electrolytic cell. Electrolytic cell, or in short we say voltmeter. Voltmeter, not voltmeter. Voltmeter is used for to check the voltage difference. Rather, this is voltmeter, or in short, the common name is electrolytic cell, right? Okay, so before we write the note, we just copy this diagram. Lighting of the by the lighting of the bulb, or we can say by the bulb becoming illuminated,